Bismillahirrahmanirrahim. My name is Sadaf Iqbal and welcome back to Programming Fundamentals and Introduction to Computer Programming. I'm back with functions in C, and today we will discuss another scenario in which we return multiple values from the function. So let us see the lecture outline. Lecture outline: return more than one values from a function, and we will see how it can happen with examples. Then we will recall all previous topics of function and do some more examples related to functions. So coming towards the main topic, that is return multiple values from a function. In previous lectures, we have seen that the function is returning just a single value. Either it is returning nothing, or either it is returning a single value to a function from a function. Now, if we see how we can have more than one values from a function, return more than one values from a function by using the method call by address or call by reference. So this is one way in which we can return multiple values from a function. So we have to call the function by address or by reference. That is similar the case which we have discussed in, I think, lecture number 4, in which we have discussed the how we can call a function by reference. What happened in that? We used special kind of variables that can store the addresses, and those variables were known as pointers. So here we will be using pointers. We can actually make it happen to return multiple values from a function. Let us see some examples. So here's an example. This is the function definition. We will come back to it. First of all, let us see the main function. Here we have main function, and in the main function we have declared 3 variables, a, b, and c. A and b are integer type and c is the character type. What happened when we write this code? In memory, a and b and c, they will be allocated some memory space, right? So let us see. A, B, and C, 3 variables will be allocated some memory location. Suppose it is the address of A is 111, and suppose the address of B is 112, and the address of C is 113. Now when we call a function similar to the function when we call it by reference, we are doing the same thing over here. We are calling a function named initialize. This is the function initialize. It is defined over here. And we are passing addresses of A, B, and C through a function. So this is actually your call by reference. So here we are not passing variable A, B, C, but we are passing the addresses of A, B, and C. So what is the address of A? That is 111. Address of B is 112. Address of C is 113. So the value 111 is copied to where the function is defined. Here it is stored in pointer A, and address of B is stored in pointer B, and address of C is stored in pointer C. This is the difference. If you can relate with the previous examples, the normal functions in which we are just returning one value. If you notice that here we used variables, but now we are using some pointers, and we are passing addresses to these pointers, right? So what happened if we use pointer A? If you recall, you should know that pointer A is actually referring to the value inside that address. So it will go to the value that is present in pointer A, that is 111, and it will allocate value 10 to that location. So after this implementation, A will be 10, B will be 20, and C will be A. So that is how Now, if you want to print the values of A and B and C, you will have the output, that is A will be 20, B will be A will be 10, B will be 20, and C will be E. I hope it is clear now. We are actually passing the addresses, and here we have pointers, and by using the pointers, we are allocating the values, right? So at the end, we are getting three values, like A, B, C, and we are initializing their values. A is 10, and B is 20, and C is 8. Okay, let us see another example that will be more clear to you after seeing that. Okay, define a function that can return quotient and remainder after dividing two numbers from one single function. So we have to make a function that can return both quotient and remainder of two numbers. So this is the code. So this is the definition. The first lines are the definition of the function. We will come back to it. Let us see the main function first. Here we have integer A 76, B 10. You can also you can also make program in which you let the user enter the number, right? Here we have defined the numbers. A is 76, B is 10, integer Q R. So after this code, what will happen? We will have A 76 and its memory location is 111, suppose, and a variable B with value 10 and memory location 112. These are just assumption, okay? And we have also two other variables. We have not assigned some values, but we just have declared. So Q and R with memory location 113 and 114, both are integer type. Now what happened? Here we have called the function div. And we are passing two variables, that is A and B, and the addresses of other two variables, that is and Q and R. So what after this code, the compiler will go back to where the function is defined. And here integer A will receive 76 value, integer B will receive 10 value, and integer pointer quotient will receive, as it is the address of Q, it will receive 113. And integer pointer remainder will receive address of R, which is 114. So quotient will have 113 and remainder will have the address of R. Now this is the code in which what we are doing, we are replacing the pointer quotient is equal to A by B, A divided by B. The value of A divided will be stored in the location, the address that is pointing this variable. So as quotient is pointing 113, so it will go to that address and will assign A by Q, the value of A by Q, to this variable Q. And similarly, remainder, it will go to the pointer remainder will go to the location 114, and here it will assign A remainder B, the value of A remainder B, right? And after these curly brackets are closed, the command will go back to where it was the function was called. And here, if you print quotient and remainder, Q and R, you will get quotient is 7, as A divided by B, quotient we get 7, and remainder is 6. And here 6 value will be stored. So that is how we can get multiple values from a function, right? Turn more than one values from a function using call by reference. We can say call by address or using pointers. So far we have learned function definition, function prototype, how to declare a function, how to define a function, how we call the function. These are the syntaxes: definition, prototype, and calling a function. we have discussed in detail in previous lectures. We are just concluding our functions in this lecture. Okay, we have return type in definition, we have the function name. These are the formal parameters in function definition, in function and declaration. The parameters list, they are known as the formal parameters. Then we have body of the function in the function definition. We have no semicolon in the definition. And in prototype, if you don't write the names of the parameter list, just the return type, that is fine with the semicolon. Okay, when you call the function, you call it with the same name. And then these are the arguments, and these are actually your actual parameters. Then we have discussed call by value, call by reference. In call by value, we know that both actual and formal parameters, they are in different memory locations. And whatever we task perform to formal parameters, that have no effect on the actual parameter. On the other hand, actual and formal parameters are in the same, they're sharing the same location, memory location in call by reference. We're using pointers to store the address, and formal parameters can actually change your actual parameters. Okay, then we have discussed types of user-defined function. We have seen there are 4 types in which, for example, void function and no parameters list inside the brackets. So this is no argument, no return type, and no argument, right? No return value and no argument. So no. Here the next is integer and with empty parameter list. So that means the integer type is the return value. So it is returning some value with no arguments. Here we have no return value, and here we have argument. And here we have both the arguments and the return. And we have discussed these 4 types of user-defined function in detail in previous lecture. Okay, let us do some more examples to understand functions more deeply. This is an example. Okay, that was in that is void. Acha. Okay, what you have to do. You have to tell the output of the following C program. Let us see step by step. This is the function f1 integer a integer b. Okay, we will come back to these functions. First of all, let us see the main function. Main function. In main function, we have integer a is equals to 4, b is equals to 5, and c is equals to 6. And here we are calling 2 functions, f1 and f2, which are defined over here in the left side, f1 and f2, right? In f1, we are passing a and b. If you recall, this is your function called by value. We are passing the variable, right? And in f2, we are passing address of b and address of c. And then we are printing c minus a minus b. So let us see what will be the result of c minus a minus b stepwise. Okay, coming towards the first function. First we are calling f1, a comma b. So what is f1? f1 is over here. f1, now look at it. What is f1? f1 is integer a, integer b. So a is receiving the value of, what was a? If you see that a is b and b is 5, right? A is 4 and b is 5. So a is 4 and b is 5. So we are passing 4 and 5 over here. And then inside the function, we are declaring another variable c. And what we are doing? Well, in first step, c is equals to a. So one integer c, when we define it, declare we have an empty box, right? C, and it has nothing inside it. Okay, in the next line we say c is equals to a. So whatever the value of a is, that is transferred to that is copied to c. So in that, c will have the value 4, right? Then next step, a is equals to b. In B we have 5. So now A will be 5. So A will be 5, right? Then we say C is equals to B. We have 4 in C and we are copying this value to B. So B will become 4. I hope it is clear. I will repeat it, okay? We have A 4, B 5, and we have another variable C, which is empty at this moment. At first line, C is equals to A. We are putting value of A in C. So we have 4 in A, we will put 4 in C. Is that clear? Then A is equal to B. We have 5 in B. We will copy this 5 in A. So now we have 5 in A. And then we copy the value of C to B. We have 4 in C, so we will copy 4 in B. So at the end of this program, what will happen? We will have A5, B4, and C4. Then at the end of these brackets, the compiler will go back to where the function was called, over here. But as we know that when we call by a value, it does not affect the actual parameters. If you want to print after this, if you want to print A and B after this line, you will get the same value. A is equal to 4 and B is equal to 5, because whatever you do with the formal parameters in call by value, that will not affect the actual parameters. Okay, coming towards the next function. So the next function, we are passing addresses, address of B and address of C. So let us see the next. Okay, this is the next function, F2. Now, what we have in A, as we have passed address of B, address of B and address of C. So suppose address of B is 1000 and address of C is 2000. So when we pass these values to pointer A and pointer B, here we will get A 1000 and here at B we will get 2000, right? And inside the function we have declared another variable which is C. It is empty at this moment. Now what we are doing, C is equals to pointer A. Whatever is present in pointer A, it will be copied to C. So you can see, wait a second. So what we have here in pointer A, we have address 1000. Pointer A means that in pointer A means that it will access the value of this address. So when it will go to 1000, which is, if you see this picture, 1000 is this address. So it will access the value inside this address, right? So value of this address is 5. So it will put 5 in C. Okay. So in C we will have 5. Now coming towards next line, pointer B is equals to pointer A. In pointer B we have 2000 value, right? It will go to 2000 value and access the value of this address, which is 6. So now what will happen? It will replace the value of pointer A, which was 1000 and which is actually this address, and will convert the value of this address to 6. Is that clear? When we are using pointers, right? So pointers which will actually access the value of that address. As here, the pointer B means value of that address which is inside B. So value of 2000, the address of 2000 was 6, right? Now 6 was copied, and pointer A means the address of which is present in A, it will go to that address, and which is 1000, this one, and it will repair. Pointer A means it will access the value. So as we are assigning the value, so this will be copied, the 6 will be copied over here. Now after the second line, this line, at B we will have 6 and at C we will have 6. Now after the third line, C is equals to pointer B. Now at C we have value, it is just a variable C, so we are just looking at the value which is 6 over here, right? And we are, what we are doing, we are making it is equals to pointer B, which is uh, so remember, C was pointer A at the first step, that was C was 5. This C, this A, B, C, they are within this function. Remember, don't mix with the one in the main function. In one with the main function, B and C, these are these values, right? So here, the C was pointer A, which was 5, right? So what happened when C is equals to pointer B? The 5 value will be copied to B now. Now B will have 5 and C will, yes, C is uh, C is 6 and B is 5. Now if you want to execute C minus A minus B, you can see we will get, now we have A is 4. If you can see, A is 4, that was defined in the main function, that is A is 4, B is 6 and C was 5, because now when we're using call by reference, then these values have been changed, right? B and C are changed because here we are passing the addresses of B and C. Now if you do C minus A minus B, you will get C is 5 minus 6 minus 4, and you will get the result. Let me give you, just repeat these things so that they must be clear. C is equals to pointer A. Pointer A contains 1000, right? This is pointer A, it contains 1000, and 1000 address is actually the address of B, right? And B contains 5. So C will store value 5. You can see over here. So C has value 5. For the second line, pointer A is equal to pointer B. Pointer B is 2000 and it is referring to this point, this value 6, right? Because this is 2000. So 6 is copied to pointer A. The value of pointer A is addressing this address. So, and it is 5. So after this line, pointer A is equal to pointer B, 6 is copied to this address. So B and C both will have 6 values, right? And pointer B is equal to pointer C. What is pointer B? Pointer B is this address, which is addressing C, the value of C, and is equals to C, this C. This C was 5. You can see over here, this was 5. So 5 value will be copied to the address where 2000 address value, right? So this value. So 5 will be copied to C, right? And B was 6. This should be 6. B was 6, C was 5, and A was 4. So that is how we get A 4, B 6, and C 5. Another example, convert binary to decimal number. Okay, here what we are doing, we have our function named convert. This is our main function. We have declared a long n integer C. Enter a binary number, and then it will call the convert function, and it will return a value which is stored in the C. And here we have printed n and C. Okay, what is convert doing? That was function declaration, and here the function is defined. Integer convert long n. Integer decimal is 0. Okay, we have declared a variable, initialize the value with 0, and I also with 0, and here another variable remainder, right? So while n is not equals to 0, the loop will go on. Remainder is n remainder 10, n is equal to n divided by 10. This is the formula how you convert the binary to decimal. Okay, here you will see that we have called a predefined function, that is power, POW, that is for power, and it has two arguments. If you see, I have given an example, x of y. So x will be the first argument and the power y will be the second argument. So 2 and I. Here we are using 2 and I. Okay, let us run this example in code block and see whether we get the same result. This is the same code. This is our function. This is our function. It is converting the binary to decimal. So enter a binary number. Let us enter 111. So it will tell that 11 in binary is 7 in decimal. So that is the end of the topic functions. I hope you are able to actually make different functions. You are able to define them, declare them, call them, and you know how to return the value. And it is all depend upon what you want from that function, right? If you want the function to return a value, a single value or multiple values, or you don't want the function to return any value, so it is up to you. You have to decide which strategy you want to do and which category of functions you want to define, right? So this is the end of the function. I hope you have all understood this topic. Thank you.